on this one. Okay, so we're going to redo problems 6 through 9 on the previous page using the calculator. So on number 6, so if we flip back, what was this question asking us to do? Find the proportion. Okay, so the way that you're going to do this is you're going to hit calculate. So you got to be in the calculator on your calculator. So sorry. So you're going to hit calculate. Okay. Then you're going to hit menu. You're going to hit probability. So number 5. You're going to open up the calculator.
Oh.
Yeah. So you're going to be on that calculator screen. Okay. Hit menu. You're going to hit 5, which is going to be probability. Okay. Then you're going to hit 5, which is distributions. Okay. And we're going to do normal CDF. Okay. Normal CDF. Okay. You're going to put the lower bounds, which is negative infinity. Go down to the next thing. Upper bounds, which is going to be 1.72. Okay, so lower bounds is negative infinity. Upper bounds, which is 1.72. What was the mean on this one? Do you remember? 1.84. And what was the standard deviation? Okay, so you're going to put in all of that information. So again, normal CDF. Type in all that information. And what does it give you?
Unsupported feature. This feature
Does it give you error? All right, hold on, pause. Okay, he would really like his lap times to be consistently between 1.75 and 1.85. So we're gonna do the exact same thing. We're gonna do normal CDF. I got you. Give me 1 second. And your lower bounds on this one is gonna be 1.75 because that's what they said. We want our low to be. Our high is gonna be 1.85. Our mean is 1.84. And our standard deviation is 0.07. Type that in, see what you get. No, look at yours. What? What? All right, try that really quick. Make sure that you get the same answer. The upper bound is 1.85. They want us in between those two numbers. Lower bound, let's do.
Bro, what?
What's wrong with you, Mel?
No, then it's the infinity that messed it up.
Okay. Try it. Okay. For the next one, everybody got 0.4575? 0.4575 on number 7? We okay? Yeah. The lower bound goes first, then the upper bound. They told us that we want to be between 1.75 and 1.85. So low to high. Mean, then standard deviation. Okay, so here it is again for my visual people. Standard deviation was given on the other page. Yeah, it was based off of this one. Okay. Say it again. No, because they gave us a lower number. Yep. Okay. Ready for the next one? Number 8. Okay. On 8, it says, in what proportion did he take more than 2 minutes? Okay, so the lower bound is gonna be what number? 2. What's the upper bound gonna be? Okay, good. And then mean's the same, standard deviation is the same. Are we okay? You should be able to do the drop down and it should be one of the options. Is it not? No? Bring it to me. Hold on. It's not an option on there. Perfect.
That's why I don't want to go.
Or maybe it's just his calculator. But hit control. And then there's like a little book on the right-hand side. It looks like an open book. Click on that, and then there should be an infinity symbol on there. Okay, when you type the word infinity, did infinity pop up? Okay, so you can just type in infinity if you want to do it that way. Good. Okay, so looking at number 8, did you get 0.011? Yes. Okay. Good. We okay? I'm gonna throw a curveball in just a second. Yeah. Okay. On number 9, this is the part where you're probably going to see this the most often on the multiple choice section. So here it is. Okay. This time they want us to find like kind of the reverse. So this says what lap time is necessary. So what lap time is necessary for Mr. J to be in the fastest 3% of all lap times. Okay. So kind of the same setup that we did a second ago. You've got to make sure that you're in that calculator mode. Okay, you're going to hit menu. You're going to hit 5 for probability. You're going to hit 5 for distributions. Okay, so menu. Let me do this as I'm talking it through. Okay. Menu, 5, 5. And then you're going to hit 3, which is inverse normal. Okay. Now, when you do this, you're going to hit inverse norm. And you're going to type in the area. So we want the top 0.03%, right? Or 3%. Then we want our mean. And then we want our standard deviation. Okay, so mean, standard deviation. When you type that in, you should have gotten 1.7083. 0.07.
I got that.
We okay? Okay, now here is the great part. If you completely forget how to do the math, this makes it easy, but you gotta know the keystrokes in order to actually get there, right? That's the tricky part, okay? You also gotta remember what goes in, right? Fortunately, most of this is prompted, so it tells you, hey, what are you supposed to be doing? But you've got to remember where it's located. Cool? Are we okay on this? Okay. Tomorrow on the quiz, though, this is how you check your work. This is not how you do your work. Does that make sense? Because you still got to show me what you're talking about. Okay? Cool? All right. This is just an option. You don't have to use the calculator on this part because we have all the formulas. Yes, ma'am. Because we're going up to 1.72. It's from the left-hand side until 1.72. Because he could have been 0 seconds, right? That would be crazy, but yes. Okay. Everybody okay? All right, let's go back to 2.2. Okay. Remember, I will give you the copy of the how to calculator with everything on it. I did put it on your Google Classroom, so if you need to go back and refer, it is there. Okay. All right. let's get back to this. Okay. So we're gonna go over answers, and then if we need to go over how to, then we can. All right, on part A, the z-score was -0.5. Is that what you got? Everybody okay? Do we need to go through it? Okay. How did you do it? It should be 5.25. Yeah. Yeah, there shouldn't have been a whole lot of variation on that one. Interpret the z-score. So what does it mean? So remember, we got to talk about context. So what are we talking about here?
Movie.
Number of Star Wars movies this person has watched is 0.5 standard deviations below mean of 5.25 Star Wars movies. Okay. I think the interpreting the z-score is probably the hard part. Remember, context, talk about where your standard deviation is, talk about the mean. You got to state numbers. Don't talk in generality. Okay. Yep.
So not to list out the data, even though they already got it.
Yes. You're acting as though the reader has not paid attention to what has been going on the entire time. Yep. Exactly. Okay. All right. Sadie has scored a z-score of 1.1. How many Star Wars movies has she watched? How many did you come up with? 8. Okay, good. 8 Star Wars movies.
Wait, how'd you do that?
How'd we do it?
Find
Find X. Okay, so we have X minus the mean divided by the standard deviation, right? They give us the standard deviation. They give us the mean. They gave us the z-score. Now we're solving for X. Yeah. So we would have 1.1 equals X minus 5.25 divided by 2.5 and then solve, right? No. He's got so long before that. All right. Number two on part A. Okay. Good Lord. Okay. Book Harry Potter and the Prisoner of Azkaban is 317 pages long. Calculate and interpret the percentile. What'd you get? 43rd percentile. Okay, now here's the deal. This word means you've got to talk about it in context. So the way you would say this is the number of pages in Harry Potter and the Prisoner of Azkaban is greater than or equal to 43% of the books in the Harry Potter series. Interpret means to put it in context. Okay? Is everybody okay on that? Greater than or equal to 43% of the books? If I'm in the 90th percentile, I'm 90% greater than everybody else who's taking that test, right? Good? Okay.
Harry Potter books or the same books?
Harry Potter series. Yep. Yeah. So the number of pages in Harry Potter and the Prisoner of Azkaban is greater than or equal to 43% of books in the Harry Potter series. I like that notation. That's cute. Okay. All right. Calculate and interpret the z-score for Harry Potter and the Prisoner of Azkaban. What'd you come up with? Z-score was
negative.
okay. Z-score was negative 0.78. Way you would have done that is we got 317. We subtract the mean. The mean was 486.7. We divide by our standard deviation of 217.2. Right? Okay. Then we go to our z-squared table and we find it. Okay. All right. Part C, the book Harry Potter and the Chamber of Secrets is 251 pages long. Without doing any calculations, compare the z-score of this book to the z-score of Harry Potter and the Prisoner of Azkaban. Okay, so will the z-score for Harry Potter and the Chamber of Secrets be lower or greater than the z-score for Prisoner of Azkaban?
Okay.
Okay.
You know,
Here's the mean in the middle. Is the Chamber of Secrets less than the mean?
yes.
Yes. Is it less than the Azkaban book? Yes. So it's going to be lower than or negative. Everybody good? Because it's farther away from the mean.
Wait, less than.
Less than.
That's what I wrote. What is it?
All right. So the Chamber of Secrets will be lower than the z-score for the Prisoner of Azkaban. Yes. Because it's lower than the mean. All right. Everybody okay on that? Okay. Number 3, Gina is examining gas prices across the county. She randomly selects 10 gas stations, each from different states, and records the gas price. Average price per gallon of the regular gas is $3.31. The gas station located in California has a gas price of $4.66 per gallon and a z-score of 2.04 from standard deviation. What'd you get?
Is that right?
I don't like this answer, but 0.662.
Oh, yeah.
But like it should be 66 cents because that's how we measure money. Yes. Yes. All right. So they tell us that average price is $3.31. They tell us that the z-score is 2.04. And they tell us that this is the gas price in California, right? We know that the formula is D equals X minus X bar divided by the standard deviation. Okay, we're given X, we're given the mean, and we're given the z-score. Okay, so let's plug in. 2.04 equals 4.66 minus 3.31 divided by the standard deviation. So what am I going to do first? I can subtract up here. So what is that going to give me?
1.25.
1.35 divided by the standard deviation. How do I get this from being on the bottom? I can multiply by the reciprocal, or you can multiply by the standard deviation and then divide by 2.04. Yes? No? Okay, watch. You either multiply by the reciprocal or you can multiply on both sides. It gives me 1.35. Divide by 2.04. It's the same thing. We're saying the same thing. So 1.35 divided by 2.04 should give you 0.662. Good? Okay. All right, number 4. Values A and B are 2 different data values from the same distribution. Value A has a z-score of 1.4 and value B has a z-score of negative 2.1. Which value is farther away from the mean? Which one's farther away? Why? Larger absolute value. So it's farther away from that mean, right? Okay. Which value is at a larger percentile? Value A, why? Okay. Everybody okay on that? Yes, no, maybe.
What was the explanation for A?
So for A, value B is farther from the mean because the z-score has a larger absolute value. For part B, value A is at a larger percentile. And that's because value A has a positive z-score, which means it's above the mean and has a percentile greater than 50%. Value B has a negative z-score, which means it's below the mean and has a percentile that's less than 50%. Cool. Okay. Do we finish 5? No? Okay. Are we feeling a little bit better? A little bit. Okay, go ahead and do 5, 6, and 7, and 8. Sorry. Yeah, they're multiple choice. You'll be fine. Well, some of them are. Yeah. Yes, ma'am. All right, go ahead and try 5, 6. One thing I do want to come back to here because I know this is a little bit confusing. This Prisoner of Azkaban book is longer than 43% of the books. Does everybody understand that? So that's why it was greater than. Does that make sense? I know that we've talked about the percentile being less than or equal to. There are ways to phrase that where you can say greater than. Yeah? Okay, I just want you to be able to compare it. Okay? So just be mindful of that. Okay? You got to be exact with your wording. Okay, let's move on to 5. All right, a part of the training program, an experienced pilots take an online reaction speed test. Oh, that's fun. All right, the reaction time for the test is 273 milliseconds and a standard deviation of 82. Reaction time has a z-score of -0.9. What was the actual score? And that should have been 199.2 milliseconds. Don't forget your units. Don't forget your units. Okay. Say again. That's normally meters per second.
And slash s. But
Yeah.
s is millisecond, literally, where'd you get them?
I think they would be okay with that, yeah. Okay. Tommy's takeoff reaction time was the same amount of time away from the mean reaction time as Fiona's, but his time was not the same as Fiona's. How is this possible?
He had a positive z-score.
Okay, so he was above the mean. Okay, so he had a positive z-score. Okay, what was Tommy's reaction time? You guys should.
346.81 seconds. Did I do wrong?
No, that's right.
Oh, okay.
I'm using the MS for David.
Missed it.
Yes. Yeah. Okay. All right, number 6. You're given this awesome table. Okay. Who has a higher starting salary? A business graduate with a z-score of -1.2 or a communications graduate with a z-score of 0.7? Right? Okay. And when you explain, you're going to talk about the values. So the business graduate salary should have been 784.2, and the communications graduate salary is 61,109.4. Agree? Yes. Okay. All right. On B, Lindsay is one of the business graduates who's earning a starting salary of 72,000. Luke is a communications graduate. Starting salary is 65,000. Which of these two graduates has a higher starting salary relative to the graduates in their respective majors?
Blue.
Okay, why?
Well, he's using the max of communications graduates, whereas Lindsay is just a little bit above the median.
Okay. So Lindsay would have a z-score of what? Lindsay would have a z-score of 0.35. And Luke would have a z-score of 1.29. Right? So Luke's salary is more standard deviations above the mean salary for communications graduates than Lindsay's salary above the mean salary for business graduates. So exactly what you were saying, just use those numbers, right? Yep. So remember, we want to use numbers to be specific. We can't talk in generalities, right? Okay, that's okay. Remember, z-scores allow us to compare two things that have two different means. So that makes it a little bit more of a stronger explanation. Does that make sense? So like you didn't say anything wrong. You just, it's not as right. Okay. All right. On part C, for which group of graduates, business or communications, would it be more surprising to receive a starting salary of 60,000? It would be more surprising for a business graduate to receive a starting salary of 60,000 because it would have a Z-score of negative 1.67, while a communications graduate with a starting salary of 60,000 would have a Z-score of 0.53. So that goes back to our conversation of Z-scores allow us to compare two different things that aren't the same. Does that make sense? Okay. Yeah. Good. Everybody says sure. All right, number 7. What is this person's name? Is it Veda? Vida? No.
It's like a J, it's from J.
I guess. Veda. Okay. She's from like some type of Russian country. Okay, which of the following is the closest to the Z-score of the maximum fuel efficiency? So the following is the closest to the Z-score of the maximum fuel efficiency. How do we find this?
Best thing to do with kids.
Okay, so what'd you get? 2.62. Okay. All right, what about number 8? The shoe size of American males is normally distributed with a mean of size of 10 and standard deviation of 1.5. Okay. What is Emmeline's shoe size? 7.5. All right, are we feeling more comfortable with this? Okay. For your quiz tomorrow. You got to be able to interpret percentile, calculate the median lifespan of something, find the Z-score, use the empirical rule. What's the empirical rule?
You ask me if I'm smart.
Go to Google, type in. Okay, so we're knowing that 68, 95, 99.7.
Yes.
Yeah, so if we're in 1 standard deviation, we're at 68%. If we're in 2 standard deviations, we're 95%. If we're 3 standard deviations away, it's 99.7.
Correct.
Good. Okay, those are the 3 numbers you need to know. Okay. If I asked you to actually draw the normal distribution, could you do it? Like if I gave you a mean and a standard deviation, fill in this up. Okay. Okay. I'm gonna take off that last one. All right, questions so far. Okay, I'm gonna give you time to do your recommended assignments. You should be able to get through both of them. Okay, so hopefully you've already started on them. Remember, they're due tomorrow night. I need you to make sure that you can access the textbook. Okay, so should be on your portal. Okay, other things. A lot of you still have not joined AP Classroom, and we're gonna start doing some stuff on AP Classroom, but I need you to be signed up first. So I'm going to put the code up on the board in just a second. Yeah. Yeah, go ahead.